Hello everyone, this is Dr. Shochinandan Datta, and in this video lecture I'll talk about the basis of stock assessment or the fundamental of stock assessment, and this is the part 2 video. So first thing, we have checked few concept of the stock assessment, and first concept is the stock is each and every species of any fish population is totally separate. So stock, there is no exchange of the species, or maybe there is a little exchange, and it could be interbred and it could not be, but basically it's not interbred to each other, but sometimes it's one stock is interbred to another stock. Second concept is the stock assessment. It's a multi-step process. And it's first it's required to the management questions that gives you that what is the impact of phishing on the whole stock, and that includes the process of involving the data collection. That is a very important point, that in case of assessment the stock, the important point is the which process you are taking to collect your data. And there is a various different sampling method for collection of the data. I'll talk about later. And the model selection, I have talked about already. It's the three types of model. The one is the surplus production model, swept area model, and analytical model. So which model you choose for your stock assessment, and then you assess your stock by using that particular model. And then you have to give after getting your result, after getting your output, you have to give the recommendation or your policy recommendation to the decision maker or the policy maker. So this is the whole process. And the third concept is the stock assessment model provide a very simplification process of a very complex system. So fishery is a very complex system. There is lots of the things out there. So it's not only the biology, it's required lots of environmental to biology to socio-economic to economy to political. So everything will be, it's a very complex process, but very simply we can estimate the stock very simply. And it's help us to estimate the population changes, how over time. So due to time changes, the how the population is changing. And it's also help to give the prediction for the future stock. So from the stock assessment we can also predict for the future stock, and that help us to take the management policies and management action. And concept 4 is the stock size fluctuates. So stock size is always fluctuating, and it's fluctuate. There is a 4 key processes. I have already talked about it. The main 4 processes is the 2 additive process. One is the growth and recruitment, that gives addition to the stock, and 2 subtractive processes, that are the physical mortality and natural mortality. Due to this death, it's going out of the stock. So this is the 4 key processes of that make the stock fluctuate. Next thing is the overall purpose of the species management is to know the life history of the species, the status of the stock. So that is the main objective. And the stock assessment includes lots of mathematical and statistical model that analyze the stock production and also help to future prediction. And it gives you a quantitative forecast for future, and to give to make a fisheries management policy, and gives few questions of the fisheries management. So what are the 3 main questions for the fisheries management? First question is the present, past, and the future. So what is your present stock now, and what was your present stock earlier, and what will be your future stock if you are taking these alternative management choices. So past, present, future, that stock status, this is the main 3 key questions for the management of this stock. So what the aim of the stock? Aim of the stock to understand the natural history, understand the bio life history of that particular species, and understand the harvested species and their interaction to each other. So they are interacting to each other due to the predator interaction and different biological processes, and understanding the population dynamic of that particular living marine resources. So here I have talked about 3 different models. So analytical model require much more the biological data, length data, age data, mortality data, and so surplus production model is required basically the catch and effort. So we are talking about the catch and effort now. So catch, how to estimate the catch? So what are the technique, what is the methodology, what are the sampling methods to estimate the catch? So catch we can take from directly observed data or tabulated data given by the fisherman or the logbook, and we can expand it for the sample rate. We can expand our sampling rate to make the appropriate catch. And also the stratified sampling method, so it's a very popular method. So we whole population we are divided into different strata and then collect the data of different strata and compile it and to take to know the whole catch is about. And the simple random sampling design, it's a very common technique to for the population estimation. So simple random sampling means randomly we are collecting the catch from any region and to know the total catch of that particular zone or particular stock. Now, what is effort? Effort is the number of boats basically and the gears. Which gears? So it's a troll net or kill net or sign net or per sign. What is the gear is used and the number of boats you are using. So that is the effort. So we have also the effort have different issues. These are the basically the sample proportional by area. So your effort is on that region, means how many boats are operated in that particular region. That is area to effort, and then estimate the effort by gear type. Means you are giving the effort is each and every gear type have we are estimating differently. So gill net is different, so troll net is different, porcine is different. So gear type is estimated the effort is very important, and estimate the gear specific effort and that related to species catch. So effort must be species specific. Now we have talked about the catch, we have talked about the effort. Now catch per unit effort, it is a very important thing to estimate. I have talked about the, if you go for a surplus production model, then main methodology is to estimate the CPUE. So catch per unit effort, it's a given stock of a fish proportion of a particular region available stock, and that is captured by a unit effort. Unit effort means you are taking that amount of fees using that unit effort, and that effort is constant. So that is the CPUE. So CPUE is a constant and it is a ratio between the catch and effort. It's estimate through time. So CPU means how much time you are required to catch by using that unit effort to catch that unit of total population, and it's related to the overall abundance. Means it's an proxy of the abundance of the population. So collect data that will gives you the index to change the fish population size over time. And then typically the CPUE data, it gives you the how the population is changing over time. To estimating the CPU we can easily predict, and we assume the CPU is directly proportional to the population size. If your population size is very good, then your CPU will be very good, or rather on the same way the CPU is very good, then population size will be very good, and CPU is low means the population is decline, population size is not good. Now, how the CPU is related to abundance? So how we can estimate the CPU or the catchability coefficient? So Q is the catchability coefficient. It's related to CPU. So catchability coefficient is nothing but what is the probability of capture? Means if you are using that amount of hook on your region, then what is the probability to capture of fish from the 1,000 hooks? So that is the Q, and that Q related to CPU, to biomass, and fishing effort or effort related to basically the fishing mortality. So C by E mean catch by effort is equal to catchability coefficient into biomass. So C by E mean catch by effort is equal to catchability coefficient into biomass. On the other hand, if you convert it, the fishing mortality F is equal to Q by E, catchability coefficient into effort. And where is F? What is F or the fishing mortality? That is catch by biomass. So catch by biomass is equal to F. So C by B is equal to Q into E. So closed form, if you estimate the Q is equal to basically exponential of ln of catch the CPU at time t by biomass at time t by whole by the total population. So q is equal to exponential of ln of catch at time t by biomass at time t by whole population. Now long-term management advice. So long-term management policy. So optimal yield. So for the long term, we have to check the what is our optimal yield. What is the MSY? So what harvest level would be the maximize to long-term benefit. So if we harvest at that much level from the population, so it gives you a for a long term. So long term you can, I have talked about it. Will the fishermen willing to sacrifice their now catch to for a long term benefit for them? And that is also, if you go for a optimal yield for a long term, then your environment or your ecosystem is already will also be protected. And what harvest level will allow to stock to rebuild? If you, I have given a very good example of the data in my previous lecture. So if you harvest that much of amount, and what will be present, and that stock have the rebuilding capacity to recovery on that stock for the next year. And so ecosystem component is very important for a long-term management policy. So as well as the ecosystem also protected if you protect if you catch as a optimal limit. So here it's a very good diagram that we can estimate the stock, and we can see what is the status of your stock. Is it in safe zone, is it in recovering zone, or overfishing or overfished? So it's very easily calculated by the BMSY or APMSY. So biomass over BMSY to plot against the fishing mortality by fishing MSY. So if biomass is equal to BMSY, then it's okay. If your biomass is greater than BMSY, then your biomass is okay. And if your biomass is less than BMSY, means your biomass is low. On the other hand, if your fishing mortality is equal to fishing MSY, that's okay, no problem. And if your fishing mortality is much more than the FMSY, means your fishing rate is very high, means you are overfishing. And if your fishing mortality is less than your FMSY, means your fishing rate is okay, you are not harvesting that huge amount. So from this plotting, you can easily understand the status of your stock, where it is present. I mean, it is in safe zone or overfishing zone or overfished zone. For a long term data set, you can plot and you can check what is your stock status and what will be your stock status for the future also. And so I have talked about the BMSY and FMSY. So what is biomass of MSY? Biomass MSY is nothing but if you plot biomass in terms of yield. So if you plot biomass in terms of yield, then what is the maximum yield of that particular biomass? That is the BMSY. So that is the maximum yield of that particular biomass. That is the maximum yield of that particular biomass. That is the BMSY. And on the other hand, maximum yield, that is the MSY. On the same way, if you plot the effort in terms of yield, then you can check the effort in terms of yield, then the maximum yield to get in which effort, that is the FMSY. So that particular effort you are getting that maximum yield. So this is the FMSY, fishing mortality of MSY. On the other hand, maximum yield, that is the MSY. So stock assessment process. So stock assessment is a very complex process, and here's lots of data you are required. So first, to estimate a population model, normal population model, you require a catch data. That could be a commercial catch, a recreational catch, or very observed or anywhere you catch data. You can collect the catch data, different sampling methods, and using and the abundance means CPUE catch rate. What is your catch rate of how much effort you are applying to get this much catch, your abundance, and then you require the biological data, age data, growth data, mortality data. This all those three data is required to estimate your population. And this, if you go for a advanced modeling, then you have to incorporate the ecosystem into your model. So this is advanced, and this is also the long-term process. If you go for a long-term sustainability, then you have to incorporate all those parameters along with the biology. You have to incorporate the ecosystem and socio-economy. I have already talked about the sustainability. To make it sustainable, you have to consider the ecology, to biology, to social economy, and all the part you have to incorporate, and then you can forecast for the future. And you can also check the status, is it a safe zone or recovered zone, or overfishing or overfished. So this is the whole process of the stock assessment. And here I put an example of the stock of yellowfin tuna in Oman. So here the stock, we have the catch data from 1995 to 2018, and here the catch of yellowfin tuna is fluctuating. It's not constant or not increasing. And here if we look at the effort from 1995 to 2018, so the effort is increasing, the number of boats is increasing throughout the time. And so CPU, catch per unit effort, it is also fluctuating. It is not increasing or decreasing. It is almost a little bit decreasing, but it's not increasing. So this is the CPU. And here is the expected and observed catch. It is a very model fit, and your observed data, so it's a very well fit. And if you plot your expected and observed CPU, it is also, this is your observed, and this is your expected CPU through the model. And here if you plot your biomass to yield, so you can also estimate your what is this. So you have to tell what is this. So how you can estimate your this part from biomass and yield. So here we can plot the yellowfin stock status from 1995 to 2018. So if we check the yellowfin status, stock status in 1995, it was in overfishing zone, and it goes time goes, and 1996, 97, 98, and 99 and 2000 it was reached. In 1990 to 2000 it reached to a overfished. So we are harvesting a lot. So we are going beyond our sustainable limit, and then it's gaining again. It's a good, means it's recovering, or it's a little bit improving to reach to overfishing in 2004, 5, 6, 7, and then again it's reached to overfish zone due to the overharvested overfish zone till 2014, and then it's a little bit means improving our catch, or improving our stock. It's reached to overfishing, and now it's overfishing condition. So stock assessment, it required a ecosystem connection for a long-term model. So if you go for a short-term model, short-term optimal yield, then you can only consider the biological data, biomass recruitment, growth, and mortality. But if you consider the long-term data, then you have to consider the ecosystem into your model. So long-term optimal yield ecosystem is required along with the biological data. So single species assessment tool, your single species biology, then ecosystem, these all things gives you optimal yield for biology for short term, and ecosystem plus biology gives you a long term optimal yield. And this research is also always connected with the ecosystem. And the indicator, there is how your stock will be it's indicated by the environmental to ecosystem to various ecosystem or physiochemical parameter of the ocean, that is oceanography is also incorporated in. So ecosystem best estimate the changing of mortality, that is the natural mortality and different other mortalities. So that is the whole process, how the stock assessment is connected to your ecosystem. And so in summary, so we look the life history tool or life history parameter is required for your analytical model, and catch and effort data is required for the surplus production model, and catch need to be estimated through stratified sampling method. It's a very common sampling technique for the population estimation. And efforts need to be collected gear specific, gear type, and standardized. It should be standardized effort. And effort needs to be species specific, means you are collecting the tuna by using the different gears, and if you are collecting the pelagic fish by using the gill net. So effort species specific. And catch divided effort is the CPV. It is also a proxy to the abundance. and BMSY and FMSY is required for to estimate your stock status. So these are all about the stock assessment part 2. So this is all about the stock assessment. Thank you.